Welcome to qnawire.
Here I'm going to solve the problem which is shown in the screen. I've previously submitted the solution for the same problem. However, I made a tiny mistake when I was calculating the direction of the force. So here I'm going to walk you through the solution again and correct the previous mistake. So here, we have to calculate the force which is created by the electric field and which is acting on the charge 2. This force is created by two electric fields, by the electric field generated by 2-point charges, charge 1 and charge 3. So our solution of this problem will be divided into two parts. First, we are going to refine the geometry of the system, and we are going to refine angles and distances which we need to calculate the force. And then we will calculate the force which acts on the second charge. Let's do the geometry part first. So as we know, angle 3P2 equals to angle 3P1 equals to 90 degrees. And we also know that this guy, angle 132, is a straight angle. Distances between charges 1 and 3 and charge 3 and 2 respectively are the same and equal to A. Therefore, the angle 3, 2, 1 equals to the angle 3, 1, 2 equals to 90 degrees over 2 or 45 degrees. So this angle is 45 degrees. And also the distance between charges 1 and 2, according to the Pythagorean theorem, equals to the square root of a squared plus a squared, which is a multiplied by square root of 2. Okay, and we've refined the geometry, and now we can find the force. Let's redraw this system again. So here are our charges 1, 3, and 2. And let's repeat the signs of these charges. Q1 and Q2 are equal and both negative, while Q3 is positive, right? Right. So therefore, the first charge will act on the second charge with a repulsion force, which will be directed to the right bottom corner of the screen. So this is F12. And F12 is a force at which charge 1 acts on charge 2. Charges 3 and 2 have opposite sign, therefore they will undergo attraction. And F32 will be directed from charge 2 to charge 3. So F32 is a force with which charge 3 acts on charge 2. So now let's write down the equation for F2 in the vector form. F2 vector equals to the vector sum of F12 and F32 according to the superposition principle. Now it's time to introduce the axis. Let's direct y-axis downwards and the x-axis to the left. So now let's sketch the projection of the forces. So F32 will be completely projected on the x-axis and it doesn't have any vertical component, while F12 has both components. So this is F12x and this is F12y. So as we said, this guy is 45 degrees. Therefore, this angle is also 45 degrees because these two angles are between one line and two parallel lines. So now let's calculate the x projection of the force acting on the second charge. So f2x equals to f32 projected on x minus f12 projected on x. So this guy equal, and here I want to mention again that we are going to use the absolute values of each component because we've already taken into account the charges. So f32x equals to f32 and f12x equals to f12 multiplied by cosine of 45 degree. So it equals to f32 minus f12 over square root of 2. Okay, now let's find f32. f32 equals to k multiplied by an absolute values of q2 multiplied by q3 divided by the distance between charges 2 and 3 squared. So the distance between charges 2 and 3 is a, therefore this guy equals to k q2 q3 absolute value over a square. Okay, now let's calculate f12x. It equals to f12 over square root of 2, and f12 in turn equals to k multiplied q1 multiplied by q2 divided by the distance squared between points 1 and 2. So this distance, as we said, equals to here a multiplied by square root of 2. Therefore, this equation becomes k multiplied by absolute value of q1 q2 over a squared multiplied by 2 square roots of 2. Okay, now let's calculate the x component. f2x equals to k q2 q3 over a squared minus k q1 q2 over a squared multiplied by 2 square roots of 2. So let's simplify this expression. It becomes kq squared over a squared multiplied by absolute value of q3 negative q1 absolute value over 2 square roots of 2. Again, it equals to, numerically it equals to 9 power multiplied by 10 power by 9 newtons meter squared over coulomb squared multiplied by q2, which is 6.5 coulombs divided by 5.00 divided by 1000 meters all squared. And also multiplied by q3, which is 3.30 10 to the minus 9 coulombs. Negative q1 is 6.5 over 2 square roots of 2. Now let's calculate this value. So I need to use the calculator again. So it equals to 0.00234 newtons or 2.33 millinewtons. Okay, now let's find the y component of the force. Y component of the force is generated only by the F12. So therefore it equals to F12 projected on y-axis. Again, absolute value because we've taken sign into account. And it equals to F12 multiplied by sine of 45, which is F12 over square root of 2. Now let's complete this calculation. F12 equals to K Q1 Q2 absolute over distance 1 2 squared divided by square root of 2, which equals to K Q1 Q2 over a squared multiplied by 2 square roots of 2. Now let's calculate this number. Equals to 9 multiplied by 10 power by 9 Newton meter squared per Coulomb squared multiplied by 6.5 multiplied by 10 power by negative 9 coulombs multiplied by the same charge divided by 2 square roots of 2 and 5.00 multiplied by 10 power by negative 3 meters all squared. So let's calculate this number. It equals to 0.005378 newtons, which roughly equals to 5.38 millinewtons. Okay, now we found the y component. Now we have to find the total value of the force, total magnitude of the force. Let's sketch the system again. 13.132. So here F2x directed to the left, F2y directed to the bottom, so directed down, and as we know F2y is more higher than F2x. So nevertheless the total force F2 will be vector sum of these two forces. And its absolute value equals to the square root of squared F2x and plus squared F2y. Basically according to the Pythagorean theorem from this triangle, right triangular. Numerically it equals to 2.34 squared plus 5.38 squared millinewtons, which is, okay, let me use a calculator. So it equals to 5.87. No, yeah, 5.87 millinewtons. Yeah, let me double check myself. Yeah, this number seems to be correct. Okay, and lastly, uh, we have to calculate the direction of this force. Again, let's label this angle as angle alpha. So alpha is the angle between F2 and x-axis, or the line which connects charges 3 and charge 3 and 2. So from the triangle shown here, alpha equals to a tangent of f2y over f2x. So basically this cathete over this cathete, which is, and this guy numerically equals to f2y. And this is obviously f2x. Or numerically it equals to 5 point, sorry. Numerically it equals to 5.38. Yeah, a tangent of 5.38 millinewtons over 2.34 millinewtons. Now let's complete this calculation. So it roughly equals to a tangent of 2.30, which equals to 66.5 degree. So this is the correct answer to this question. So alpha equals to 66.5 degree, and the force, the resulting force, is directed to the left bottom corner of the screen. So let's summarize our findings. First, Fx equals to 2.34 millinewtons, and it's directed to the left, and yeah, Fy equals to 5.38 millinewtons, sorry, and it's directed down. Then F2 equals to, absolute value of F2 equals to 5.87 millinewtons, and the direction of F2 is angle alpha, which is 66.5 degree, and again this angle is between F2 and x-axis. So here is a summary of the answer to this question. I hope I helped you. Thank you very much. Bye.